Welcome to solverfy.
This is the answer to Chapter 16, problem number 7 from the Smith Organic Chemistry textbook. And this problem asks us to draw all possible resonance structures for the cation that we're given here and indicate which structure makes the largest contribution to the resonance hybrid. Okay, and so in order to draw resonance structures, we're going to move electrons around. So the first one we can draw, we can just move the electrons of this double bond over. And so that is going to give us a resonance structure that looks like this. So this double bond is still right here. We now have a double bond there, and our positive charge is going to be seated right there on that carbon. Okay, so our next possible resonance structure is going to be moving these electrons to here. And so when we do that, we get to this structure. So here we go. And our positive charge is now going to be on this carbon. And so lastly, we can have one of the lone pairs from this oxygen add in there. And that is going to give us this resonance structure. And so we now have a double bond here. The oxygen is only going to have one lone pair on it, and it's going to have a positive charge. And so this final resonance structure is going to be the one that makes the greatest contribution to the resonance hybrid. So this last structure makes the greatest contribution to the resonance hybrid. And there are several reasons for that. So all of these atoms have octets in this structure. So that's good. They all want to have octets. There are more bonds in this structure. So there's one more pi bond in this structure that is not in the three previous ones. So more bonds. So that's going to be more stable. So that's good. And then also our charge is on the most electronegative atom in this molecule. Charge on most, and I'll say E negative for electronegative atom. And so that is something we do always want to consider. We want charges and lone pairs and things like that to be seated on electronegative atoms. Oxygen is the most electronegative atom in this molecule. And so therefore it does impart some extra stability to have the positive charge seated on it. And so that's why this fourth structure is going to make the greatest contribution. Yeah, and so here are all the resonance structures again, and that's the answer to Chapter 16, problem number 7.